Hello and welcome back to Keeping It Cool Liquid on the Data Center Cooling channel. I'm Emma Brooks. I am the channel manager for the Energy and Sustainability, Construction and Investments and Markets channels here at DCD. And I'm delighted to be joined by three industry experts for this episode on cooling the AI revolution in data centers. And again, thank you to Isotope for supporting this episode and making it possible. So joining me today, we have Jason Mattison, who is the VP for Customer Solutions Architecture at Isotope. So hi, Jason.
Hi.
Nick Ewing, Managing Director at Efficiency IT. Thanks for joining me, Nick.
No problem. Good afternoon.
And John Gross, who is the President and Mechanical Engineer of JM Gross Engineering. Welcome, John.
Hi, thank you very much for having me.
Thanks very much for joining. Brilliant. So kicking us off, sort of getting straight into the conversation, I want to touch around some of the liquid cooling adoption challenges. So these can be both cultural and technical, but obviously we are seeing many operators now kind of keen to explore some of the opportunities that liquid cooling can provide. So with this, obviously, the two worlds of facility and the IT have become connected. Two worlds which traditionally were less connected, but obviously we're now seeing some of the challenges around there. So keen to explore how some of those can be overcome. So yeah, Jason, I'll come to you first for your thoughts on this, if that's okay. What are the implications of this, I suppose, these marrying up of these two worlds, and how can better communication be facilitated?
Yeah, well, first of all, great to be here. Really good question. And this actually really touches on a critical point of the journey to liquid cooling and some of the challenges that the industry face. And I guess the best way to kind of explain the need and the implications here is to really kind of understand the basis of where we're coming from. Today, for your standard air-cooled data centers, you've got your data center design operators, facilities operators that ready the data center for being able to host racks in rows and hot aisle, cold aisle layout strategies and architectures. And the IT administrators or the buyers of IT, they can pretty much buy, servers that meet their needs, and they're delivered to the data center. And for the most part, they can be deployed in racks inside of the data center. With the advent of liquid cooling, and liquid cooling is absolutely here now and needed. There needs to be a coupling between the facilities, these people that design, build, and operate these data centers, and the compute that's coming into the data center. They're now coupled tightly together. And what I mean by that is, regardless of the server manufacturer and the liquid cooling technology type that's included, these need to be connected into and ultimately connected into the facility's cooling infrastructure, which typically comes in the format of chilled water cooling loops. So today you have, you might have air handlers where you have chilled water under the floor that comes into the air handlers, and it basically provides the cooling into the room. Now with these liquid cooling architectures, these racks are deployed, which need to be connected into manifolds, which are connected into TCS or technology cooling systems, cooling loops, which is isolated and different from the facility's chilled water loop by a coolant distribution unit. And so now you can see that facilities, chilled water or cooling systems need to be coupled to the IT rack through this interface. And so, when you're looking at new designs, but certainly even with existing designs today, there's definitely going to be a kind of a need for this tighter communication between those two sides of the industry, really, which really has been almost a chasm in the past.
Just a quick one, sorry to jump straight in with another question for you, Jason, but where do you see most of that conversation coming from? Is it being led by facilities, or is it being led by the IT guys? Who's kind of leading that conversation
Yeah, so I mean, that's a really good question. I don't know if I
Sorry,
have
completely threw you with that one, but
yeah, I
I
don't
just
know
think
if
it's
I
quite
have a really
interesting.
good feel of that. We engage with both sides of the equations, right? I would say that the advent of AI, it's really IT is driving the conversation
Yes, yeah, yeah, yeah,
more
yeah.
so. But at the same time, the requests are coming through to the facilities, operators, and so there are several kind of industry forums and conferences where again, this topic is front and center, whether you're on the facility side or the IT side. But make no mistake, it's the IT, the power at
Yeah,
the
yeah.
CPU and GPU level, which is driving the need for liquid cooling, which is basically pushing the industry.
Yeah, and that I think that's probably the answer that I was expecting, because that's where we see the requirement coming from. It's been driven by, as you say, the researchers, and that request comes down to IT, and then ultimately it's IT talking to facilities, and bridging that chasm, as you very very politely
Yeah,
suggested. They've got to work together now, right? They
that's
have
right.
to work together to be able to deliver this,
Yeah,
because it's a very multifaceted system, isn't it? Now that we're going into.
Yep, for sure.
Yeah, absolutely. And
yeah.
you mentioned, sorry, go on.
No, I was going to say, I think one of the other things that we're running into is that the industry is evolving so rapidly, the technology is evolving so rapidly, and we don't yet have all the necessary standards in place to really kind of open source, if you will, the infrastructure and the IT solutions, right? We're coming from a world of air cooled ITE where those standards, those power and thermal standards, have been around for several years. And so a lot of this stuff is kind of ubiquitous, and you can just kind of plug and play however you want to. And we're not quite there yet with the liquid cooling side of things. And we're seeing a lot of changes. And what we're seeing on the infrastructure design side is that it's really a question of, is the if you're talking to a facility that's being designed for a specific tenant, it's being driven by the IT side. If you're talking about a co-location facility, it's being driven by the facility side, trying to figure out what their potential tenants might need. And because it's not ubiquitous yet, there's a lot of difficulty trying to figure out how to make that facility more open and available to a number of different solutions.
And we were chatting about this the other day, John, because that's kind of where we're stopping. We're involved in designing and building these facilities, and liquid cooling is one of the things that's coming to us all the time. But we're creating the infrastructure to support that. So either coolers, or dedicated systems, and the bit that we stop at is the manifold. We'll provide you something to this manifold, but we'll stop there, because at the moment we have no, every single customer, every single requirement, every single system is almost unique. So I think standards, as you say, John, I think standards at the moment are probably one of the biggest things the industry is missing, in order to be able to make the route to adoption of these kind of systems a slightly more straightforward approach.
Yeah, definitely. John, you touched on the design element there. I mean, from your side, I know that you mentioned previously that the most liquid cooled facility hardware is kind of designed in size for sort of smaller clusters of hotspots in legacy data centers. I guess how are you seeing sort of that sort of shift to more widespread from a design point of view?
Yeah, that's a great question. There's been a narrative for a while in the industry that liquid cooling is new and it's niche and whatnot, and it's neither really. It's been in the HPC world for decades. We've known how to do it for a long time, but kind of to your point, a lot of those HPC clusters tend to be comprised of a small quantity of racks relative to a traditional enterprise or colocation data center. And so, what we've known how to do really, really well is to design and deploy this infrastructure and operate this infrastructure for, maybe a couple dozen racks, right? And that has a certain look, it has a certain feel. There's different things that you optimize around when you've got a relatively small footprint, a relatively small quantity of racks. And as we're trying to go to this scale up, where we're talking about now people where instead of talking about say like a 1 or 2 megawatt HPC, or maybe even a 5 megawatt HPC. People are talking about AI clusters that are pushing, 30, even 60 gigawatts. I'm sorry, megawatts as kind of a standard size that people are going to. And when you start looking at the physical infrastructure and the logistics of getting that much power and that much cooling to 60 megawatts worth of racks at 100 plus kW per rack, it really kind of becomes very daunting, because a lot of the things that we have done kind of by default for the last 20 years, the way we've done hot aisle containment solutions and where we've run cable tray, where we've run power, how we've distributed cooling, we kind of all know how to do that, and we're having to go back and rethink it. And when we start doing it at the scale that we're trying to do it for these AI clusters, even a lot of those things don't even really work anymore. We have a lot of conversations around heat capture ratio, which is the percentage of the heat in the server rack that goes directly to the liquid cooling solution. And if you talk about, say, an 85 or 90% heat capture ratio, which sounds really good on the surface, that you're getting 85 or 90% of the heat directly into the TCS loop, and extracting it out of the data center without air, you still have 15% left over. Well, 15% of a 25 kW rack is really not that big of a deal. It's not that much heat. But when you start talking about 15 kW or 15% of a 100 kW rack, that's a 15 kW air cooled rack. So we still have a significant air cooled portion in these liquid cooled data centers that we have to think about. How do we actually get that heat out, get it out efficiently, do we have hot aisle containment there, and how do we actually synergize all that infrastructure with the liquid cooling distribution, with the fact that we're now running 3, 4, sometimes 6 power feeds down each row to try to power these racks. It's really kind of a very interesting game of Tetris, and we're still kind of trying to figure out, how to optimize that.
And it's not just the liquid. That this is the challenge, isn't it? It's getting that amount of power. Getting 100 kilowatts to a single rack position is an immense challenge. A row of 10 kilowatts, you're looking at massive amounts of power, and we've still got to factor in redundancy. We've still got to factor in resilience. Mm-hmm. So we're talking about doubling up. So it's really, you're talking about almost the byproduct of heat at being a 15 kilowatt rack, and those values are massive. So the whole thing has got to be. It's not like it's almost a redesign. It's almost a completely new concept that we've got to consider, and how to deliver that. That's one of the things that I guess we're seeing. We're working in smaller enterprise environments where we're seeing hybrid environments more than anything. So to your point, we've always got air. There's still a massive amount of infrastructure that's always going to need air, and certainly needs air at the moment. But then it's segmented pods away from the maybe the enterprise compute, where we're seeing specific AI loads, and that's where we're seeing maybe the less efficient cooling systems, where we're using liquid to air inside the in CDUs inside the room. Would be better if we were seeing more dedicated systems, so that we weren't having to go down a less efficient route. But that's we're seeing that because people have got these chilled water systems using air, and we've got to use everything that's given to us.
Yeah.
So it's really it's almost a complete step change. Sorry.
No, I was going to say, I think you kind of you alluded to a very important topic, right? Which is, if you are designing a new facility from greenfield condition for liquid cooling, that's one challenge, right? And if you're taking an existing facility that supports air cooled and you're trying to deploy liquid cooled, that's a completely separate challenge.
Yeah, absolutely.
There are a lot of things that are similar in both, but I think the single biggest one that you have is, you're designed around maybe 15 or 20 kW per rack air cooled, and now you've got to go and do something with liquid cooling. And I think one of the things that I've found a lot of clients having the hardest time wrapping their head around is if you have a legacy data center, and it's not even really fair to call them legacy because this transition is happening so rapidly. But if you have an air cooled data center and you're trying to deploy liquids, you're going to have stranded white space. That is the nature of the beast.
All day long. Yeah.
And at the end of the day, that you don't want to have stranded assets, and that white space is a stranded asset. Uh, but if you are in a situation where you just simply have to densify because that's what your business needs, or that's what your tenant business needs, you're going to consume your power and your cooling in a much smaller area. And you're just going to have stranded space. And so then you kind of start going down the rabbit hole of what other business uses can I have for that space? I don't want to leave it empty. Is there something else I can do with that space? And I think the other challenge that we see happening right now is we have in an air cooled data center that uses water based cooling, chilled water, facility water, as opposed to DX. You typically have one facility water system loop and one temperature system that's running. And in a traditional liquid cooled HPC, you also have a single facility water system, and where you've got your TCS loop going direct to chip, and you've got your rear door heat exchangers. Traditionally, they've run those off the same temperature TCS loop, but there's actually energy efficiency gains to be had by doing multiple loops at different temperature regimes that you can economize at different temperatures. So there's a lot of thought process that really has to go into how you actually design and develop your FWS systems and your distribution to maximize the efficiency. Because it used to be that a 5 megawatt or a 10 megawatt data center was a big data center, and I think the smallest one that we're talking about to a client right now is 60. That's the smallest.
And that's ridiculous,
Mhm.
right? That's ridiculous. And that's just not even a huge amount of white space. If you're working on what you're working on, 100 kilowatts a rack for liquid cooled, 150 capacity for 150, it's a fraction of the space that we'd be looking at it with and you made a really good point earlier. There's not even legacy data centers. There are still data centers now that are being stood up that are 5 kilowatts a rack, 10 kilowatts a rack, because there's still that demand. This has crept. It's not crept up on us, but this has just exploded over the last 6 to 12 months. And so your point about it's not legacy.
Yeah.
This is current world. They're still being. It's ridiculous.
Yeah, it's kind of funny because I know we've got to get on to the next topic, but I do want to mention.
Yeah, of course.
I do
Sorry.
want to mention. I do want to mention one thing that you kind of touched on. You said this hasn't really snuck up on us, and I personally agree with that. So Jason and I met and have worked together several years for the last several years through ASHRAE TC 9.9, and back in 2019. I was part of a team. I believe Jason was on the team as well that wrote a white paper, kind of giving folks the heads up that liquid cooling was coming, and it was going to be coming to mainstream data centers. And that was back in 2019, and we had folks from the silicon manufacturers, the server manufacturers, all participating in publishing that white paper, and we were kind of giving folks ringing the alarm bells 5 years ago, and here we are, and I think once we hit that inflection point, I think it kind of took over a lot faster than any of us expected. But there's a bunch of us within the industry that have kind of seen this coming, and we're kind of curious at what point we were going to really hit that inflection point. And I think we have our answer now.
That's right.
Yeah, completely agree. But and I apologise. We do have to move on at some point, and one of us will stop talking eventually. But none of this is new. It's been around. We've been using chilled water and liquid cooling for forever. It was only a matter of time, as you say, before this technology kind of becomes mainstream. How mainstream? Different. Everyone's got a slightly different view on that, but it's absolutely coming. It's hit us like smack bang in the middle of the face almost in the last 3-6 months, and there's no getting away from it now. But I'll stop talking. Sorry.
No, not at all. It's great hearing how passionate you all are, and sort of how many. I wish that we had longer than the 45-50 minutes that we have. But just to move us forward, so we can sort of cover as much bases as possible. I want to dive a little bit deeper into what sort of Jason said around sort of the impact of culture and alignment. Because often when in the context of liquid cooling, it's often about the technical aspects, but obviously this is just as important, if not more so. So Nick, if I could come to you first, you mentioned sort of a lot of the enterprise data centers kind of don't have liquid cooling facilities. They have to sort of go to this brand new system. So how do you ensure everyone's aligned with regards to the transition from the C-suite to the operations staff to kind of the IT as well?
Well, I don't think it's a brand new system. That's one of the things. It's not a brand new system. There are certainly in enterprise data centers there are going to be environments that are using liquid and air already. So we're going to have chilled water in the data center, for example. In enterprise data centers, we will see refrigerant as well. We'll see DX systems, so split systems. And we're talking much smaller than the kind of environments that John and Jason talk about. 60 megawatts. That's not necessarily an enterprise data center. So we're working with much smaller systems, and they have a bit more flexibility. So we're seeing hybrid environments is more than anything where we do have specific enterprise environments. So standard x86 environments, where we are 2, 4, 6, 8, maybe 10 kilowatts of IT, mixture of networking, storage, and standard compute. And then we're seeing dedicated areas, which is where people are adopting liquid. And for those environments where they do have a bit more flexibility, we're seeing dedicated systems. So we're seeing a completely separate water system dedicated for maybe 1, 2, 3, 4, 5 racks of IT, and then possibly if there's capacity in the power system, using the existing power system, and if there's not capacity in the power system, then a secondary system. So it's not necessarily a completely new system. It's an addition to an existing environment, and I think that requires less change or less adoption to a wholesale change of cooling system, but it means that people are having to adapt very quickly to a different kind of technology, and it's how we manage that. And the biggest thing that I'm seeing is people stepping over that threshold. There's that kind of that nervousness about actually taking the plunge, and I think one of the biggest things that we're trying to do is educate people around what it looks like. It's really no different to what they've always had in their data center. Certainly if they've had water in their data center, chillers and chilled water systems. So if they've always had HPC, then they've probably always used some kind of liquid cooling in their data center, because air, you're not using DX for 20, 30 kilowatts in a rack. You're using chilled water. So they've always had it there. So it's kind of getting over that step, that adoption barrier. And people are nervous. People are nervous about liquid in this form being right on top of their compute. So there's a couple of challenges in the enterprise world, but I think the last, and we've said this already, the last 3 to 6 months have just been game changing in that world. And I think anybody that was nervous about it now is kind of changing their viewpoint, and it's not nerves. It's kind of how can we use it now, and how can we deploy it? But that also comes down to, and it's a completely different topic, but what does a business require? Does business require liquid cooling? Does liquid require? Does the business require that kind of technology in the first place? So lots of different questions that we're seeing in the enterprise space, but barriers to adoption are rapidly dropping. They're rapidly reducing, and people are now far more comfortable at all levels about liquid in the data center. And IT people just want to get their hands on it, right? They just want that power. They just want that capacity. They want it yesterday.
Yeah, that makes a lot of sense. And as you said, I feel like there has been a bit of a paradigm shift, as you said, from people feeling a little bit, yeah, a little bit
Massive,
nervous about liquid
massive.
cooling to kind of more, I suppose, more on board with the idea. As you said, it's just about sort of getting that messaging right. And Jason,
Yeah, it's not should we or can we? It's when
yeah,
are we?
yeah, and we'll do a little summary on the end, actually, on your views on sort of the timescales for liquid cooling. But yeah, Jason, I'm keen to hear your viewpoint as well. I mean, what have you seen from the organisations that you've worked with, and how do you change that messaging according to the different levels of technical understanding? Because obviously, different departments will have kind of different priorities, from like C-suite individuals to the IT staff, etc.
Yeah, so conversations definitely span the gamut, right? You can have technical conversations where people really understand that you can get high performance cooling, and you can enable next generation highest performing SKUs, at the same time offering up to 30-40% energy savings at the data center level. You can talk about saving power inside the server by removing the fans and going to liquid cooling and using pumps, which is much more efficient, right? So you can have these technical conversations, but it really comes down to can you deploy the solution that has the highest performing part in it for their application and their needs. And ultimately, right, and one of the challenges that I think that we see is that and we talk about the easing into liquid cooling in the industry, and we talk about, right, AI driving liquid cooling now, and John's right, we've been talking about this for the last 4 or 5 years, saying that the time was coming where the CPUs and GPUs were going to reach a point where liquid cooling was required. But guess what? The industry's been talking about liquid cooling offering benefits for sustainability reasons, right, and saving that energy. And 30-40% overall, the data center is not to be sneezed at, right? Those are significant numbers. But when you talk to these different stakeholders, oftentimes people are making buying decisions based on CapEx discussions, right? Not necessarily about OpEx. And so this is a conversation that we certainly find ourselves challenged with, is that, right, if you have a 1 year return on investment, or 2 year return on investment, in some cases 6 months return on investment, depending on what you're paying for energy, right, that still may not be a conversation that we can have, because people are just saying, well, what's the on cost, if you will, or the extra cost associated with actually having to adopt liquid cooling. And that's a real challenge, right? Because we can clearly demonstrate TCO, right? We can talk about how the savings can be had. So these key stakeholders in the industry, depending on who you're talking to and where the money is coming from, it can be a very challenging conversation, as we've been talking about here. And I think this is all part of the education process. And if liquid cooling in the industry is going to accelerate to be able to enable and unlock doors and be able to provision, this next generation compute, then we've got to be able to accept that OpEx has to play a major role and critical role in these decisions. Just one final point. We kind of talked about the Nick mentioned, kind of enterprise, and designing power at much lower power thresholds than, and data center design points being much lower than what John talks about. The reality is, and I know we're going to touch on this here shortly. AI, I view it as the great disruptor, right? So and what I mean by that is AI, machine learning, right? These applications can be deployed in high performance compute data centers, but equally they can be deployed in enterprise. They can be deployed in colo. They can be deployed in hyperscale. They can be deployed at edge, right? You can have edge compute that needs these types of applications. And so, right, the kind of the industry, 10 years ago, 5 years ago, you might go to supercomputing conferences, and you might be talking, you might be looking at the top 1 to 3% liquid cooling users in the industry. But that was a very specific market segment. But now, right, these workloads and this kind of like, these 50, 60, 70 kilowatt rack power thresholds are real in all market segments. And so, some of the conversations that you might have had then are very different now, again, with completely different and new stakeholders, than what you would have imagined, and sooner than would have been expected. So, it's a very interesting time in the industry. There's no doubt that the performance at chip level and the need for liquid cooling is driving this conversation a lot sooner. But it is important that the key stakeholders and the decision makers, have a more pragmatic conversation around, the overall benefits of liquid cooling and the savings that it can actually offer you, right, when you're going through your analysis.
Yeah, no, Jason,
Can I
that's
ask?
a great point that a couple of great points you touch on there. So there's a number of different ways that you can highlight the value kind of to the C-suite with liquid cooling. Uh, we see the energy piece being one piece, right? We're able to run much lower PUEs. We're able to run much lower WUEs, and in many cases, we're working on solutions that have WUEs of zero, which is great from an energy perspective. I think the other thing that we try to highlight when we're looking at this is with the temperatures that you have in liquid cooling solutions combined with the thermal density that you have. In other words, the amount of energy that you have in your heat carrying pathways, right? When you have it in a liquid form instead of a gaseous form, it becomes a lot easier to do heat capture and reuse. And in some parts of the world, that has now been codified that you have to have some percentage of heat capture and reuse in new data centers. It becomes a lot easier to do that with liquid cooling, a lot more efficient to do that. And so you can take that heat and you don't give it to neighbors or so on and so forth. You sell it. It becomes a revenue stream that you can use to pay back the capital costs of the infrastructure necessary to sell that heat to your neighbors. But it also requires a paradigm shift in how the site selection is done and how the design team, the IT team, the C-suite, so on and so forth, the real estate team, they're all working together to identify good sites. Right now, we're in this position where there's such a demand to build data centers that the focus is on where can I get power, where can I get connectivity, and where can I get real estate, right? If I can get those three things in the same spot, I'm good. As we go forward and we look at some of these other constraints that we have, as an industry, we're used to looking at our neighbors and evaluating them from a risk profile perspective. How is that neighbor going to potentially cause my data center to go down? And obviously, for business purposes, that's something that you have to worry about. But now, with the heat reuse opportunities that liquid cooling avails us of, we have the opportunity to look at neighbors as potential partners and and see if they are a potential customer for that heat reuse. And if they're a potential customer for that heat reuse, one, it helps me get past some of the regulatory issues I have in some locations, but it also gives me a revenue stream. And CFOs love revenue streams. So if we can give them that, then that helps on the ROI. I think the other thing that we have to be very cognizant of as well when we talk about specifically retrofit applications is, you mentioned the amount of server power that we pull out of a liquid cooled server and give back to the facility because we're no longer using that server power to drive cooling fans. If we're doing an immersion solution, all of our cooling fans are gone. If we're doing a direct to chip solution, a lot of the cooling fans are gone, but not all of them, most of them. And we've actually worked with clients that had said that they ran out of power, not only at the UPS side, but also the generator side and the site utility side. And they had hired us to come in and help them figure out, okay, let's go have conversations with the utility. We need more incoming power. We need to add more UPS. We need to add more generator. We need to add more chiller in order to expand our facility. And we kind of looked at it and said, guys, you're running an air-cooled HPC here, and you're running a very high PUE because you're doing an air-cooled HPC at 45 to 50 kW per rack. We can actually free up a lot of capacity to add compute to your facility without actually changing any chillers, without changing any UPS, without changing any incoming site utility, simply by making your next tech refresh a liquid cooling tech refresh. That particular client, for I'll call it cultural reasons, decided not to go that route. But it's an opportunity that avails itself pretty much of any facility that is looking at an air cooled infrastructure where they are tapped out on their utilities. They can increase their actual compute that they're putting out by going and transitioning to liquid cooling, whether they are running HPC AI or they're running enterprise loads. So I think that's something that really needs to be discussed more because, you know, it's the AI that's been driving us to finally adopt liquid cooling at scale and in non-HPC environments. But by no means is HPC and AI the only thing that can really leverage liquid cooling for improved operating cost, improved sustainability, and so on and so forth.
Do you just a quick one? I've been furiously writing some notes, and this has been mentioned a couple of times. Operational efficiency, OPEX. At what stage does liquid cooling, and you both mentioned it, at what stage does liquid cooling really become the de facto for these high workloads due to energy efficiency alone? Because I mean, we see people, we see some of the and there are 3 or 4 different styles of liquid cooling, and we've all mentioned them. But we're seeing PUEs of sub 1.05. I've seen 1.02, 1.03. That's insane. Is that message coming across strongly enough, do you think, in the marketplace? Because I see too many people turning down these kind of super energy efficient systems because they're a little bit out of the norm still. And people just go, oh, do you know what? No, we'll just go with this system. It might cost us a little bit more money, but that's okay. At what stage does this energy efficiency conversation become real and tangible? And that's one of the things that I think liquid cooling is going to have a huge impact with, because you can't do it any other way. So it's almost going to be a byproduct, of this technology that we're being driven into. And then another one of your points was liquid cooling has been around for a while, and it's not just this AI conversation that's turned everything onto its head. It's not just these GPUs that's changed the dynamic. You could have a far more efficient cooling system if you took a traditional x86 server and put it into a full immersion system, or use some kind of precision immersion system, or direct to chip. Massive energy efficiency gains. Take as you said, take the fans out of a server, and there's X amount of power, increased reliability, X amount of power, stranded capacity reduces, actual usage of your electrical capacity goes on compute rather than wasted on cooling. So when do you guys think that operational efficiency argument is really going to hit the front pages, if you like?
So I'll let John answer the when question, but let me kind of put a little color to the energy savings real quick. So fortunately or unfortunately, I've had the privilege of designing air-cooled servers for about 20 years. So what I can say about the cooling power inside of servers, and this really kind of comes down to power, kind of unstranding power. Servers of yesterday, they're architecting and allocating up to 10% of the server power in the cooling subsystem inside of the server. The servers of tomorrow are allocating upwards of 20% of the server input power in the cooling subsystem. So that means if I had a 2 kilowatt server, tomorrow, we're talking about 400 watts of cooling overhead, right? That's been architected into that system. Now, if you have 20 of those inside of a rack, you can see how that power adds up. If you're doing liquid cooling, right, that 10 or 20% becomes 1 or 2%. Right. So there's an immediate savings on the server power side. And then at the data center level, right, we we can project, right? And I think that several in the industry do 30-40% energy savings possible, right, at scale. And so you asked the question about when we'll adopt, and again, I'll defer to John, to try to look in the crystal ball there. But I would say that some of the challenge in having the conversation around OpEx, and my point back to people are making purchase decisions on CapEx and not really OpEx, is probably, when people think about PUE or partial PUE, right? I don't think people really understand what that really means. So if you say, I've got a cooling PUE of 1.4, but I can give you a cooling PUE of 1.05, right? I don't think people can really grasp what that means. But if I were to tell you that, and we frame this discussion a little bit differently, and I were to tell you that, think of that cooling PUE as a cooling tax, right? So actually, let's put dollars to it now. Think of it as a tax. That means if I have 1 megawatt
or
pounds,
to
right?
it.
But if I have 1 megawatt of server compute in your data center, and I've got a 40% cooling tax burden rate on that, that means I have 400 kilowatts of cooling infrastructure power required just to support 1 megawatt of IT. Right now, if I can convert that to liquid cooling, first of all, my 1 megawatt of IT goes to 900 kilowatts or perhaps 800 kilowatts. So there's an immediate savings there. But now that cooling infrastructure tax burden, instead of being 400 kilowatts, if it's 1.05 cooling PUE, now you're talking about, a 50 kilowatt, or five, I mean, you're talking about a substantially lower amount of cooling infrastructure tax burden rate. So that's where, when you start kind of, changing how people can view the data, I think it becomes a lot more powerful,
Yeah.
right? And
Changing
the
the
message,
narrative, right?
Yeah.
exactly.
And Jason, we do a lot of the same things. So when we're having conversations about trying to do cost leveling, right, between, well, this is how we've always done an air cooled data center, and this is what it's going to cost us to do a liquid cooled data center. There's two main things that we try to focus in on. The first one that is really what you just talked about. So a 30 megawatt data center that's air cooled, with today's technology, today's servers, out of that 30 megawatts of critical load, you're getting about 25 and a half megawatts of actual compute power done, right? That's what's actually going to the chipset. Whereas if you do that for a liquid cooled solution, and let's say it's a solution that has, as you said, a partial PUE of 1.05, you're now talking about somewhere north of 29 megawatts, and that you're getting of actual power to the chipset. So what you're doing is you're really making up, you just freed up 4+ megawatts of compute. So when you look at the cost to build, the cost to deploy, and you look at the revenue stream, you don't look at it as a 30 megawatt facility to a 30 megawatt facility. Look at it as a 25 and a half megawatt facility to like a 29 and a half megawatt facility. Level everything based on that. The conversation really starts to change there, right? And then the other piece that we try to talk about is, yes, the cost of your liquid cooling deployment as a mechanical system is going to be higher than it is in an air cooled system. However, when you start to look at the solution holistically and you're looking at how much you're saving on electrical infrastructure, how much you're saving on telecommunications infrastructure, because we just went from, say, 10 kW a rack to 50 kW a rack. So our points of connection, our physical number of racks went down by 80%, right? That savings on the power and on the telecom communications, what we've seen in all the cost models and the project budgets that we've been part of, is it either ends up being, as a full project, either a wash on CapEx or actually cheaper to build the greenfield liquid cooling facility day one. And then your money ahead from day one, because you were cheaper to build, your OpEx is lower. And then if you've built heat recovery into it, you've built in an additional revenue stream to start recovering that investment. And there's a project we're working on right now that has a 2-mile set of lines in it that are piping waste heat from the data center to a heat host that we're partnered with. 2-mile direct bury 24-inch lines. The ROI on that infrastructure is inside of 18 months. And then after that, it's free money for the data center operator.
Wow.
Brilliant. Thank you so much, John. Really,
That's
really interesting case study there. It's been fantastic hearing all your points, and I've really loved this conversation. I'm just conscious that we've got about 5 minutes or so left, so I want to move us forward to a little bit of future gazing, if that's okay. As part of keeping it cool liquid, we love to hear people's sort of projections for liquid cooling and where it's going. So I'd like to sort of summarize, if that's okay, with asking your views on, will liquid cooling become the dominant form of cooling? If not, why not? And what are the timescales on this? So certainly we don't expect anyone to have a crystal ball, but it would be great to hear your views on this. Yeah, Jason, if I could come to you first.
Yeah, certainly. So I think the answer is certainly yes. The question is going to be, when does it become dominant, the most dominant? We talked about, solutions will be hybrid for quite some period of time. But I think it's only natural, right? If you think about it, all starts from the silicon chip manufacturers, right? It starts with the silicon, and you look at the offerings. If you were to pick one of them today, and you have 35 different potential, CPU SKUs that you can pick from, right? And the highest power ones today require liquid cooling. What you're going to see is that that's going to continue to go up, and the lower power CPUs are, of course, they're going to continue to increase in power as well, right? So what you're going to see, I think, is you're going to see a continual bleed in both CPUs and GPUs, where the kind of the more mainstream processors and graphics processing units and accelerators will all start making their way into the need for liquid cooling. You will see the industry begin to embrace liquid cooling, and you're going to start to see designs build out the infrastructure. So all new builds now should be considering liquid cooling as the major part of the architecture and the solution. You'll always have legacy data centers, and there will always be struggles, but you will see this transition to where liquid cooling will become the dominant. I'm not familiar of if you look back, history tells us there was bipolar, silicon technology reached real super high powers. This is back in the days of mainframe supercomputers, where water cooling and refrigeration were required, and then you had CMOS, and it basically the power dropped precipitously, and you're right, you didn't need that anymore, and air cooling was back. And we've reached that kind of same point. I'm not familiar of any new technology that allows us to be able to save that kind of energy at chip level. The demand for more and more compute and more performance is hitting all market segments. It just happens to be AI is the kind of the first entrant into this. And so 100%, I expect liquid cooling will become the dominant form of cooling. Time scale wise, it's going to obviously it may be a decade before it becomes the 51%, because right now we talk about AI and ML, right? What percent of the data center is that today, right? And I don't know if anybody on this panel has an answer for that, but I would guess that that's less than 5% today. But in the future, right, it obviously the trends will follow.
Absolutely. And John, your thoughts on this?
Yeah, so a lot of my thoughts actually echo Jason's, and I kind of want to augment that a little bit. So I've been asked at various conferences and presentations, how does an IT end user, how does an engineer, how does a real estate investor or developer figure out, what the roadmap actually looks like for these high power chips and the need to go to liquid cooling. And what I do is I kind of do the whole shameless plug thing, and I point them to one of the ASHRAE TC 9.9 publications that is the Power Trend Study. And that document is put together every couple of years as a survey of the silicon manufacturers and the server manufacturers, and it breaks it down based on the workload that the machine is doing. And so what you can see when you go through that book is really kind of two things. One is that there are charts in there that talk about kind of the rate of TDP increase for CPUs and GPUs. And if you go look at the most recent version of that book, which is a couple years old now, and you go back and you look at the roadmap at which these processors have actually been released to the market, you'll find out that the silicon manufacturers who wrote the content for that book actually underestimated the rate at which the stuff was going to come out. It's coming out faster than what was projected. But by contrast, when you go and you break it down based on workload, what you see is that outside of the scientific AI, ML, HPC workloads, the rate of TDP growth for the servers as a whole is not really rising all that fast. And it's because a lot of the workloads that are being used by traditional enterprise and other types of workloads just haven't seen the huge need for increase in processor power. So I think we're going to see air cooling stick around for quite a while in certain applications. I think what you're going to see is liquid cooling is going to become the de facto in HPC, AI, ML here in the next couple of years. I mean, folks are really building for that right now. Lots of the stuff that we're working on right now doesn't even really contemplate the air-cooled compute nodes at any kind of scale. I think the thing that's going to really kind of trigger the transition for the lower power workloads to move to liquid cooling is seeing some runtime by the HPC AI ML industry on liquid cooling with concurrently maintainable deployments, where best practices of how to do this and do it, with a lot of efficiency, do it with a lot of reliability and a lot of uptime. I think it's going to take some operating time there before we start seeing it adopted at enterprise, where their primary benefit to going to liquid cooling is on the energy efficiency, the heat reuse, and so on and so forth, as opposed to getting the pure compute power out of it, which is what HPC, AI, and ML are driving for right now.
Brilliant, thank you.
Absolutely. And if I could just make one quick point on that real quick, just the AI and HPC, which is driving liquid cooling, one of the biggest barriers to liquid cooling today is the infrastructure readiness. And so that is driving the infrastructure readiness. And so that preparedness allows us to have conversations about OpEx, operational savings, and the energy savings that comes along with liquid cooling for the more general purpose compute. So what you're going to see is an easier transition and an easier kind of, willing to accept, right? Liquid cooling for other applications because it will have been tried in their data centers and they will have the infrastructure, as you say, John. So that is definitely part of the equation, right? In terms of the rate and pace at which the rest of the industry begins to adopt liquid cooling.
I mean, it's going to be these hybrid environments, right? And I think your point there was absolutely bang on. HPC has been around forever, and that's probably going to be one of the things that helps move people into that new kind of technology. OpEx is a big thing for us. And people really trying to do the right thing by sustainability and their net zero targets or ambitions. But I think what we're seeing at the moment, and again, this is from an enterprise perspective. So we're talking to people about hybrid environments, air cooled, traditional x86 network infrastructure, and then a separate AI or ML or HPC environment that is liquid cooled, and obviously whatever technology that they decide to deploy. But I think standards will help. Standards and understanding. There's a group that we're all associated with, I believe, where we've just deployed a lab, and we've deployed the infrastructure to create a lab which will showcase people, and showcase technology. Really show people exactly how and how effective and how efficient a 150 kilowatt rack load can be. I think you both know who I'm talking about, and I think once we get people in to have a look at that and understand how it works and see what it looks like and see how simple it is, and actually they'll go, well, we've got that infrastructure, on our traditional chiller-based chilled water system, we're already using that kind of technology. So I think some of the barriers to adoption are also going to be understanding and moving away from this approach that these nerves that people have about deploying this kind of technology. But in answer to your question, it's certainly going to be a massive factor. What that looks like time-wise, I probably agree with both these guys. 5 to 10 years, but we're not losing air-cooled infrastructure environments anytime soon. We'll see them either in a hybrid environment or in a separate area. But they'll always be, for a long time yet, we'll have air-cooled infrastructure. But it's on its way. It's coming, and the technological gains, the energy gains, the reliability gains, moving away from horrible stranded capacity issues. I think all of those are just two massive opportunities for people to miss out on. So it's definitely coming.
A great note to end on. Fantastic. Thank you. Great to hear all of your thoughts around that. Certainly, I know that this is something we've been asking throughout our Keeping It Cool Liquid series. So yeah, it'll be interesting to see what everyone says with regard to this. But unfortunately, I am going to have to wrap it up there because we are out of time. We have run the clock down. But it was a really great conversation. Thank you so much. Thank you so much to you all for joining. Thank you to Jason. Thank you to Nick. Thank you to John. And of course, thank you very much to iZotope for supporting this episode. Do check out the resources alongside the page for more relevant information. And of course, feel free to send in questions. They will be forwarded. Feel free to connect with the speakers offline. I'm sure they'd be happy to keep the conversation going. And of course, do feel free to get in touch with iZotope as well, who I'm sure would be very happy to continue the conversation as well. Do remember this episode is available on demand for anyone who may have missed it, and do tune in just a few minutes for our next episode, which is a tech showcase. But again, thank you so much to iZotope. Thank you so much to Nick, John and Jason for joining me.